A very good morning, good afternoon or good evening to my dear students. I hope you all have understood the concept of inverse trigonometric functions that I have taught in the previous lecture. So let's move on to the properties of inverse trigonometric functions. But before starting, I wish to remind you something. You have to be tension free and be focused throughout the lecture. So let's begin. I am going to play the slideshow of the properties of inverse trigonometric functions on the screen. So please pay complete attention. Okay, so have you all noticed anything common in all these properties? What is it? Just remember what is it? We have just seen all the properties. Go back in the video. What is the property common in? What is the thing common in all these properties? Yes, it is the range of values for x which is given in each property. For example, let's consider the first property, which is sine inverse sine x is equal to x. This much is given, and after this what is given here? We have x belongs to minus pi by 2 to plus pi by 2. Yes. X belongs to minus pi by 2 to plus pi by 2. So what does it stands for? This means that if the value of x lies in between minus pi by 2 to plus pi by 2, then only this property is applicable. You can use this property only when the value of x lies in this range, means it is between minus pi by 2 to plus pi by 2. Similarly, for the other property, second property, you must have seen, it is cos inverse cos x is equal to x. When x belongs to 0 to pi, means the value of x should lie between 0 to pi, then only this property is applicable. So now I am going to explain you these properties. This will help you in understanding them and learning them more easily. Trust me. Okay, so pay attention. First one is sine inverse sine x. Is equal to x. So what is the first step? First of all, you have to let sine x as theta. So now what will be x? X is equal to sine inverse theta. Okay, this is the second step and this is the first step. So in place of theta, can you write sine x? What you have left in the first step. So you are getting x is equal to sine inverse theta. In place of theta, you have to write sine x. So see, this is the property which we have just read. Sine inverse sine x is equal to x, and that's the proof. It's very easy. Similarly, the other properties such as next property cos inverse cos x is equal to x, then tan inverse tan x is equal to x can also be proved. Okay. So let's consider the other type of properties, second type of properties, which is their proofs are also very simple, very easy to understand. Here also you can see that you have a range of values for x, but in this case that range is different. It is from -1 to +1. Okay, so this is the only difference. And see, sine inverse sine x, but here you are having first sine and then sine inverse. And this range, you have to keep in mind this range. See, this is the only difference in the two properties. So it means that same as here, that if and only if the value of x lies in between -1 to +1, then only this property is applicable. Then only you can use this property. Okay, so the proof of this property is also very simple. You have to let theta in there. This is theta now, and here also this was theta. Sorry if you didn't got the image of this page. Okay, so you have to let sine inverse x is equal to theta. So x is equal to sine theta. See, x is equal to sine theta. When you will take this sine inverse from RHS to LHS, then it will become sine. It will get attached to theta. X is equal to sine theta. This is the way in which you solve the inverse functions. Now, again in place of theta, can you write sine inverse x, which we have let in the first step? Yes, you can. So, see, what did you got? X is equal to sine of sine inverse theta. This is the property now. Sorry, sine inverse x. See, theta sine inverse x. So similarly, the other properties can also be proved. You have to keep in mind this range. Similarly, for the previous one, you have to keep in mind this range. Property is very easy to learn, but this range is a bit tricky. So the next type of properties is sine inverse 1 upon x is equal to cosec inverse x. Here also you have the range of values for x, means the value of x should be either greater than or equal to 1, or it should be less than or equal to -1. This is the range of values for this property. Now what is the property? Sine inverse 1 upon x is equal to cosec inverse x. So let's see its proof. Let sine inverse 1 upon x to be equal to theta. Now 1 upon x is equal to sine theta, and you will take sine inverse from LHS to LHS, it will become sine. So what will be cosec theta? Cosec theta is the reciprocal of sine theta, so it will be x. Now you can write theta is equal to cosec inverse x. So just compare the first and the second step. Sine inverse 1 upon x is equal to theta, and here you are getting theta is equal to cosec inverse x. You have proved the property. It is sine inverse 1 upon x is equal to cosec inverse x. Remember this range of values for x? And as the property is very simple and very easy to learn. Okay, so similarly the next property is cos inverse 1 upon x is equal to sec inverse x. Here also you have a particular range of values for x. X should be either greater than or equal to 1, or less than or equal to -1. The range is same for both the two properties, this one and the previous one that I have just dropped. So its proof is also very easy. Cos inverse, you have to let in each of these questions In this also you will let cos inverse 1 upon x. Here also what you have done? You have let sine inverse 1 upon x to be equal to theta. Then in the previous one, you are letting the angle, see sine with this angle, you let this. Here also you let this thing which is in bracket, sine x equal to theta. Okay. Cos inverse 1 upon x is equal to theta. So you have let. So 1 upon x is equal to cos theta. So sec theta is the reciprocal of cos theta, so it will be x. So theta will be ultimately sec inverse x. Again compare the first and the second steps. It's cos inverse 1 upon x equal to theta, and theta is equal to sec inverse x. So again you have very quickly come to the result. We have proved it. So and the third property of this type is for tan. It is tan inverse 1 upon x is equal to cot inverse x. Here also you have particular range of values for tan, which is in this case x should be greater than 0. X should be greater than 0. This proof is also of the same type. You have to first let tan inverse 1 upon x to be equal to theta. Then 1 upon x is equal to tan theta. Cot theta will be the reciprocal of tan theta, that is this. Now again you got theta is equal to, what is theta equal to? Cot inverse x. Cot will move from RHS to LHS, it will become cot inverse. And will get attached to the LHS. What is the LHS in this case? It is x. Cot inverse x. Again you can compare the first and the second step. These are both the same. Tan inverse 1 upon x is equal to theta, and theta is equal to cot inverse x. 1 upon x is equal to cot inverse x. So you can write this. Yes. So you have come to the proofs. So now let's take up the other type of properties. This is sine inverse minus x is equal to minus sine inverse x, and the range of values for x is x belongs to minus 1 to plus 1. Now, how will you prove this? Here also what you have to do is, you have to let the LHS to be equal to theta, then minus x is equal to sine theta, then x is equal to minus sine theta. This much is clear to you all. Now what is the next step? You can you write sine of minus sine theta equal to sine minus theta? Remember, I have also mentioned this identity in the previous lecture. This is an identity. You can write minus sine theta to be equal to sine minus theta. So, x is equal to sine of minus theta. Now, if you take the sine from RHS to LHS, what will it become? Sine inverse x is equal to minus theta. So see, if you are going to compare this step with the upcoming step, so what is the difference in the two? What you have to do to make the two steps equal? If you multiply this equation by minus 1, both the RHS and the LHS side. So, what did you get? Minus sine inverse x is equal to minus minus plus theta. So now you just compare the two steps. Are they equal? Sine inverse minus x is equal to theta and minus sine inverse x is also equal to theta. So ultimately the two terms are equal to each other. This is what the properties. Okay. Sine inverse minus x is equal to minus sine inverse x. Remember this range of values. Only there these properties are applicable, where the range of x is satisfied. So the other two properties are also of the same type. They have the same proof. That is cosec inverse minus x is equal to minus cosec inverse x, where just the range of x is different. Mod of x should be greater than or equal to 1. Here also you have to let the LHS theta minus x is equal to cosec theta. X is equal to minus cosec theta. Now again, you should have remembered this property. Cosec minus theta. Minus cosec theta is equal to cosec minus theta. So you will write this minus cosec theta. In place of this you will write cosec minus theta. Again you will take this cosec from RHS to LHS. It will become cosec inverse equal to minus theta. Multiply this equation by minus 1. What did you get? You have multiplied this equation by minus 1. So minus theta became plus theta and cosec inverse x became minus cosec inverse x. So compare the two steps. Cosec inverse minus x is equal to theta and theta is equal to minus cosec inverse x. In the same way you can prove the third property of this type, that is tan inverse minus x is equal to minus tan inverse x. The range of x in this case is that x belongs to the set of real numbers. Tan inverse minus x is also equal to minus tan inverse x. So I am not going to prove this one because it is the same as the above two which I have just proved. Okay, this I am leaving as an exercise for you all to do it on your own. You have to do it. Okay. So let's come to the other type of properties. It is cos inverse minus x is equal to pi minus cos inverse x. Cos inverse minus x is equal to pi minus cos inverse x. Here the range for x is, the range of values for x is, x belongs to minus 1 to plus 1. So let's take up the proof of this one, this property. This, again you have to let the LHS. Cos theta x is equal to minus cos theta. So here it is the property that you have for this one. This also I have mentioned in the previous lecture. You must have remembered. It is cos pi minus theta. Minus cos theta is equal to cos pi minus theta. You can write this. So x is equal to cos pi minus theta. You wrote in place of minus cos theta. So now you will take this cos from RHS to LHS. It will become cos inverse x is equal to pi minus theta. So now just put the value of theta, substitute it from the first step in the second step. Cos inverse x is equal to pi minus, in place of theta you can write cos inverse minus x. So now just move this term to the LHS. Cos inverse minus x and this term to the RHS. Minus cos inverse x. This is the property. Cos inverse minus x is equal to pi minus cos inverse x. Okay. Similarly, you have for sec inverse minus x is equal to pi minus sec inverse x. Here the range of values for x is mod of x should be greater than or equal to 1. So here also you have to do the same thing. You have to let sec inverse minus x to be equal to theta. Then minus x is equal to sec theta. Sec inverse from LHS to RHS became sec. Got attached to the RHS. Theta, sec theta. Can you write x is equal to minus sec theta? See, minus x is equal to sec theta. So x is equal to minus sec theta. So again you have the property minus sec theta is equal to sec pi minus theta. So in place of minus sec theta you can write sec pi minus theta. Now just take this sec from RHS to LHS. It became sec inverse. Again what you have to do is to substitute the value of theta from step 1 and step 2. This sec inverse minus x. Now just rearrange this. Take this minus sec inverse minus x from RHS to LHS. This is the property. Sec inverse minus x is equal to pi minus sec inverse x. Similarly, the third one of the same type is cot inverse minus x is equal to pi minus cot inverse x. And the range of values for x is x belongs to the set of real numbers. So this is also left as an exercise for you all to do it on your own. You have to do this. Cot inverse minus x is equal to pi minus cot inverse x. The proof is the same as the above two, okay? Just try it on your own. Okay. So the rest of the properties I will take up in the next lecture in the part 2 of properties of inverse trigonometric functions. Okay, so subscribe my channel for the latest updates, latest videos. Just after this I'm just going to upload the second video and share my video among your friends. Till then, take care. In the end, I wish to share my views with you all. I believe that if you are unable to find a suitable answer, better keep quiet instead of speaking nonsense.